So the next thing I'm going to do is drill these two 330 thousandths diameter holes in the top. Whenever you're working on a part like this, you always have to keep in mind the orientation, because you know all these features are located off specific surfaces on the part, and if you get the part backwards, sometimes you can put the hole in the wrong place. So what I like to do is I just, you know, as I work on the part, I'll keep it oriented to the print, and I'll just take a magic marker and just, you know, just throw the features on with a marker, just so you don't get mixed up when you're flipping it around in the vise. So this is the side we want to drill our holes in. Set it in the vise. Let's see, change out our end mill for the drill chuck. And I got a 21/64 drill here. I think that's what it is. 330 thousandths diameter. These are just bolt holes, so a drill is fine. We don't have to ream it or anything like that. Actually, getting ahead of myself here. We got to pick up the edge of the part first with the edge finder. So looking at the print, my holes are located from the left side of the part and from the back of the part. So we got to pick up those two edges. Start from the back. Run your edge finder in until it jumps sideways. Zero that axis out. Offset half the diameter. You don't have to have a digital readout to do this. You can do the same thing on your dials. Right there. This is the X. Okay. So my first hole is 375 thousandths in. From the left side, and 725 thousandths from the back. Up there. A little more vertical clearance here for this drill. Just spot it and just double check. It's supposed to be 3/8 from the side. That looks good. And what did I say, 725 from the back. That looks good. I'll go ahead and drill a hole right here. Wouldn't hurt to throw a little oil in there. I remember what I did with it. There's one. Next hole is 875 thousandths over from that. Let's go ahead and zero this one out. Move over 875. About there. care of that. Start to look a little more like the part. Now let's deburr that. Then we'll set up and do the let's do the 7/16 hole for the spindle. And make sure and keep the chips cleaned off your part all the time, because if you don't, put it in your vise, not only can it mess up your dimensions, it can also mark the part. A part like this, it's kind of a, the surfaces are kind of aesthetic. It's going to be right out in the open where everybody can see, so we don't want it full of little pock marks from the chips. So just make sure you keep all the chips cleaned off before you tighten it down. Alright, let's figure out where we need to, what two edges we need to work off of from this. Well, let's see, obviously it's a 1/2 inch radius on this arc, so our cutter is a 1/2 inch, or our 7/16 inch hole is a 1/2 inch from the front edge. Now this is where you have to be careful, because we have that 15 thousandths extra stock on this top surface, so we need to locate from the back, not from the top. So we'll pick up these two surfaces with our edge finder. Okay, now we need to move in a 1/2 inch off this surface. Right there, lock the cable down, and same from here. Half an inch. Lock this table down, or axis down. Okay, this is a 7/16 hole, so let me go grab a drill and a reamer. Okay, I have a minus 7/16, or a plus 7/16. Remember, it's 438.5. Because I want this to be a slip fit on a 7/16 shaft. And I picked a drill out, a 64th undersize for the reamer, for the pilot drill. Leave near enough stock up above, or room up above here, so let's move things a little bit. Set this back to 1/2 inch, because we shouldn't move that. There we go. Now, go ahead and spot it, check and make sure we're 1/2 inch in from each edge. 1/2 inch there, 1/2 inch there, that looks good. It's from the bottom of the part, so we're good there. Yeah, see, this should be 1/2 inch from this edge, but it should be 5/15 from over here, which it is. So drill through, and then we'll throw the reamer in and finish off another one here. Alright. Now, let's see if there's room for the reamer. Nope, not quite. Alright, now we're going to need to slow it down a little more for reaming. Which I think I'm going to go back here and slow it down even more. And definitely use oil when you ream. So this is making a 438.5-inch diameter hole. It'll be a nice slip fit on the 7/16 shaft that we make for the spindle. Okay, check off another feature. Okay, so let's drill this hole on the bottom side here for the 1/8 inch dowel and the 832 set screw. So we have to make sure and get that in the right position. So let's look at our drawing here. This is how it's oriented. So we want to put our hole right in this position, right there. So just, like I said, just use a magic marker. It's kind of a sanity check so you don't get mixed up when you're flipping the part around in the vise. Doesn't matter how we put it in. We can put it in just like it's oriented on the drawing if you want. That'll work fine. Okay, we're going to be locating off of this surface and off the back. So we'll pick those two edges up. And probably ought to take it out of back here now. There's the back. Might as well move in what we need here, 1.5 inches. Out there. And there's the left side. Need to move in 219 thousandths from the left. There. Okay, now we need to drill a pilot hole for the reamer, for the 1/8 inch reamer. I picked a number 33 drill here. That's pretty good size for that. We'll drill all the way through to the 7/16 hole. Okay, now we'll ream it all the way through. This is a 126 reamer. It's a dowel pin reamer. It's a 1,000th oversize. And then we're putting an 1/8 inch dowel pin in here. We want it to slip. Always use oil with reamers. And always turn the speed down a little bit over what you would use for a drill. Okay, that's good. Now we need to put a 832 tapped hole right on top of it. First thing we'll do is run a tap drill into it down to depth. Let's see, the tap drill needs to go down 3/16 of an inch, 190 thousandths. So let's run against the stop, run the quill against the stop, and then we'll just raise the table up till it starts drilling. Zero out the main and move up 188 thousandths or thereabouts, 190. Close enough. It's just a drill depth hole. And we'll switch out to an 832 tap. Lightly grab it with the chuck. We're going to power tap this hole. Not going down to all the way to depth because it's such a shallow hole. It's only an 1/8 inch deep, so I'm just going to start the tap and then finish it by hand. Of course, it would help if I'd move the stop first. There we go. That starts the hole nice and square. Now I can take it off and put the tap on a tap wrench and finish it to depth. I'll probably use I'm going to use an 1/8 inch long set screw in there, so I'll just use the set screw as a depth gauge and just tap my hole until the set screw is flush with the surface. Okay, this is a good place to stop. We got our slot in for the dial and all of our holes. Next thing I'll do is we'll set up and mill the radii, and also mill this this zero pad, this pad for the zero mark. That'll be in the next installment. Right now I'm going to go watch Red Wings hockey. See you then.